Hey there, this is Akshan and welcome back to a new video. And in this video, we are going to cover a very important interview question, that is, which database will you choose for this and this scenario? So you will be given one scenario by the interviewer and you have to define or you have to explain which database are you going to choose and why. The reason, the main question is why, right? So I was asked this interview question in my college placements interview. So I directly mentioned that I am not very good in DSA. So then they asked me this question, that they gave me one scenario. I'll explain which scenario it was, and then I had to answer a few questions. Like, first of all, the question was, does database affect functional and non-functional requirements? I'll explain that also. And the next question was, which database are you going to choose for this scenario and why? So I answered this for around 8 to 9 minutes, and the same thing I'm going to explain it in this video. So after this video, you will be comfortable answering this question to anyone, because I'm also going to give you some chit chits for that thing, right? Let's start. So first of all, what exactly is a database, right? So this is a question you need to understand this. And so what is a database? So you know that every computer has some memory, right, where you can store some data. Like your computer might be having 256 GB of storage or 1 terabyte of storage, right? In that storage, you can store things. It can either be files, it can either be videos, images, and it can either be textual data, right? Anything, it can be any file, anything. And every file in this earth or on this earth consumes some memory, right? And in that 1 terabyte of memory that you have got in your laptop, you can store anything. So that is kind of acting as a database. In your phone also, you have got like 16 GB of storage, or like 64 GB of storage, or 256 GB of storage, right? In that you can store images, photos, videos, anything. So that is again one kind of database, right? But when we talk about, or when we try to scale up things, like in your phone you have got 64 GB, you can store your own photos, right? But at one point of time, when your phone becomes old, it says, hey, I'm out of memory. You either buy a new phone or give me some memory card or put this thing on the cloud, right? So this happens, right? So because things run out of memory. Okay, so now as we try to think in terms of scalability, let's say this was your phone and this was your data, but the companies don't just store their own data, they have your data also. Like Instagram, right? Instagram has billions of photos. Instagram has billions of reels. It has billions of videos that they're storing it for you for free. So how do they do that? They store all of these things in databases, right? And they're also, right, databases are of various types, right? Some databases are dedicated for textual data storage, right, where you can only store text, right? Some databases are dedicated for object storage. Object means files and videos, images, these are objects, right? Some databases are good in storing these objects thing, right? Some databases are good for storing analytics data, the time series data, like the data which is related to time. Like it can either be like stocks data, or it can be CPU utilization data, right? So various databases are there and they are dedicated for various purposes. You should know that, right? There is not a single, it is not like that there is only one type of database that exists on this earth, right? There are various types of databases. So now you're clear what exactly is a database. Database is just a server where, or database is just a location where you can store your data, or where customers data are stored, right? Okay, now the famous interview question, which database will you choose for this and this situation, for this situation, and you will be given one situation, right? So first of all, we will understand how to actually choose a database. To understand, you should know when to choose a database and which type of database you have to choose. Then finally, at the end, we are going to take one scenario, same scenario which I was asked in my interview, right? And we will try to answer that. Okay, now the question is, this question also I was asked, like, does databases, or do the databases affect the functional and non-functional requirements, right? So here I would like to take some time and explain you what are these functional and non-functional requirements, right? Functional requirements means the features of your application. The features, like you can have login feature, right? Or you can have products feature where you can list down your products. I'll just reduce the font weight, right? So you can have like user login. Then you have like products features where you can list down all your products. And then you can have like payments where users can make payments, You can have like carts where you can have where users can store their products into a cart. Then you can have like wish list where users can wish list a particular product. So various features are there, right? These are your functional requirements. Like without these features, an e-commerce application cannot be made. These are functional requirements. Then we have like non-functional requirements, right? Here the non-functional requirements can be your system, your whole application should have low latency, right? Like when I'm trying to make a payment, it should be fast, it should be consistent, it should not like that from my from my account the money has been debited, but to Amazon the money was not credited. It should not be like that, right? It should highly be consistent, right? Then it should low latency means when you're trying to open the Amazon app, the product should load very fast. It should not like that people are waiting for 1 or 2 minutes to just see the products, right? So these are kind of non-functional requirements. That means these are not features, right? These are not features, but they're kind of requirements for your application, but they are non-functional. Functions means features, right? I hope this thing is clear to you, the functional and non-functional requirements of an application and how database affects it. Let's try to understand it. So databases do not affect the functional requirements, right? Databases do not affect the functional requirements, they only affect the non-functional requirements, right? You can make this e-commerce application with Firebase also, right? You can make this e-commerce application with like SQLite also, right? Hive database also. These are the local databases. You can make it, right? Your purpose will be fulfilled, right? The application will work, right? But Amazon doesn't use Firebase, right? eBay doesn't use Firebase, Myntra doesn't use Firebase, right? So why, right? That comes to non-functional requirements, because Firebase may not be able to complete the non-functional requirements of the application, of the system, right? Firebase may be like very slow in loading all the products. That's why you have to choose such databases which are fast in accomplishing the non-functional requirements also, right? Not just the functional requirements. You can make a cart feature with Firebase, you can make a user login with Firebase, you can make products feature with Firebase, you can also do payments, or like basically you can store the payments transactions in a Firebase Cloud Firestore in real-time database. Yes, you can definitely do it. You can accomplish this functional requirements with any database on this earth, but you cannot accomplish this non-functional requirements with just like any database. You have to choose the dedicated database only, right? So this was my answer, right? When to like databases, yes, it affects non-functional requirements, but it does not affect the functional requirements. So this is the answer for that question. Now I think we should move forward, and we should see the next part, the next slide I would say, that is use cases of databases, right? So you also have to think, if you are in an interview, you have to think like the use case of the database that is asked. Like interviewer has given you one scenario, right? So you have to think, or you have to find out in which use case that statement, that problem statement can be put. All right. So we have like various types of use cases, right? Some databases are good in storing metrics data. Like metrics data you may be getting from your IoT products, like a washing machine or a smartwatch, right? Let's say some machine is there which continuously sends the data of CPU utilization to the server, and the server has to store that CPU utilization data, right? And CPU utilization data will definitely be in time series format, right? At this instance, at this times second, this was the CPU utilization. At this second or this snapshot, this was the CPU utilization, right? So this is metrics, the metrics that we are getting from our client sides, right? So here you have to store like metrics data. So there are certain databases that are good for metrics data. I'll tell you which database is that. So basically one is OpenTSDB, that is Open Time Series Database, right? Prometheus is also there, right? So there are various databases that are there for metrics kind of data that needs to be stored. One is caching. Caching is important, right? So what happens in caching, or what exactly is caching? This can be another video, this can be another topic, this can be another question in the interview, but it's important to understand this caching also in this video, right? So what happens is, let's say your client is there, right, and your server is there, right? So client always makes a request to the server, and server fulfills that request with the response. So every time a client makes a request to the server has to go to the database and bring some data back, right? But what can happen in caching? Server is finding out that, okay, this kind of data, let's say this data, so client is asking many times. Client is asking for this type of data a lot of times, and always I have to go to the database and ask for this data. How about the server stores that data which client is asking again and again and again with itself in the cache, right? So there are cache databases in which you do not have to go to a database to store the data or retrieve the data. Server can communicate with a cache database. So cache databases are actually faster, a lot faster, right, than the normal databases, because they store the data in terms of key and value pairs, not in terms of collection, documents, tables and all. They just have a key and then they just have a value, right? Let's say you are making a tiny URL, or let's say you are making a app where people can put their long URLs and they will get a short URL for that, right? How about we store or we what we can do is we can allocate those long URLs some keys, right? And those keys can be stored here, and they will have a value of the whole short URL or something. Like, I'm not going into the system design of the tiny URL, but what I want to make you understand is the cache databases store the information in key and value pairs instead of tables and collections and documents or columns, and they are faster than the normal databases. That's why if the client is asking for some information again and again and again, the server, instead of going to the database, they will go to a cache database, and this process is called caching. And this is very important, or this is very significant if you want to retrieve some kind of data a lot of times in during a session, right? So this is caching, and this is another use case, right? So if your interviewer, the question that the interviewer has asked fits into this type of use case where you have to retrieve the information again and again, then you can go with some cache databases. So I'll write some examples also here. So caching, you can use Redis or you can use Memcached. These are two famous cache databases, right? Redis and Memcached. For metrics, you can use OpenTSDB, Open Time Series databases, right? Open Time Series database. Okay. So we have covered good amount of stuff, right? I hope you are doing good, and I hope you are enjoying this video. This is quite interesting because when we are beginners, or when I was a beginner, when I was in like second year, third year, I used to think that, okay, I have to make an app. Let's open Cloud Firestore, let's get an account on Firebase, and that's done. I'll get investment. It's not like that. You have to think a lot on the backend side, on the system design side, on the database design side. Then you have to start building and developing your product. Otherwise, for 10 users, 100 users, 1000 users, it is okay. But after that, problems are going to come. Your application will become very slow, right? That's why we are watching this video. Okay. So OpenTSB for metrics, caching, we have Redis and Memcached. Then is, what is CDN? There is a term here written, CDN, and object storage. Object storage, I have given you some idea, right? You can use Amazon S3 buckets, right? So these object storage stores the data. So we have data in various formats, right? You can have like, let me write it down. You can have data in terms of text. You can have data in terms of videos. You can have data in terms of images, right? Many formats the data can be. Text, okay. We saw metrics, we saw caching. Videos and images are actually called objects, right? Files are called objects, right? So there are actually file storage databases and object storage databases and blob storage databases, but we are seeing object storage databases, right? So object storage databases like videos and images, you can store in object storage databases, right? Some example is Amazon S3 buckets, or if you're a beginner, you might know about Firebase storage, right? Firebase storage is kind of a bucket where you can just go and put your images, put your videos, put your audios, and you will get a URL. Using that URL, you can access that object, right? Similarly, many companies are using Amazon S3, right? So this is an object storage database, which is a AWS service, right? Okay, this is good. Now we understood about object storage, right? Then we have CDN. Okay, can somebody pause the video and tell me in the comment section what is the full form of CDN? I made a reel, I made a short, YouTube short, and it's live on my channel. You can watch that, where I gave this example. So you did not watch that short, that is fine. Let me give you that same example over here, right? So what is a CDN? Content Delivery Network. Okay, so let's take the example of Netflix, right? So let's take the example of Netflix. So I'll choose the color of red. Okay, so let's say this is Netflix USA, right? Netflix is producing some content, and they are storing that content in US server, let's say Virginia server, right? Okay, so this is my Netflix. Okay, so Netflix has produced some content, some long series of 11 seasons, right? And or okay, stop the video and comment your favorite series, Netflix series, in the comment box. I'll also comment my favorite series. Okay, so by the way, my favorite series is Breaking Bad. Okay, you don't have to go to comment section, check it out. My favorite series, Breaking Bad. Okay, so you can also comment yours. Okay, so Netflix is building some content or developed some content or recorded some content, and they have stored that content in US server. Now you are a sweet guy and you are sitting in India, right? You are sitting in India and you want to watch this Netflix series. So every time you have to watch that Netflix series, you have to go to Netflix servers all the way to USA, bring the video back, and then play it. It's kind of bringing some lag. So how about what we can do is, in India, let's choose a famous location, Mumbai. In Mumbai, how about we make a small server, or we install one server which keeps a local copy of this Netflix movie. Let's say Netflix launched a movie. As soon as the movie is launched, the Netflix India or the Mumbai server will fetch that copy and save it with itself, right? So Mumbai is now having a local copy of that movie, right? Because these videos, these images are not going to change, right? You cannot let's say Netflix launched a movie and now they are making some changes to that movie. It's not like that, right? So that movie is going to remain the same. So how about we keep a local copy of that movie here, right? So now when the sweet guy has to watch that movie, you do not have to go to USA to bring that movie. You can go to Mumbai server. Hey Mumbai server, give me that Netflix movie, I want to watch it. Mumbai server will say, okay, here is a movie. This is not bringing lag. This is much faster than this Netflix, right? So that's how the CDN works. Content Delivery Network. The content means movies, images, everything, reels, videos, shorts. So these content delivery network is kind of a network of various geographical locations. Let's say one is this Mumbai server, one will be in Dubai, one will be in Switzerland, right? So it's kind of a geographical network of servers which are keeping local copies of the content, right? So these are called, or these are part of this famous word, the CDN, Content Delivery Network, right? So content delivery network is not kind of a database. Database is like an object storage. Object storage is type of a database, but content delivery network, you might want to explain that to the interviewer if the requirement is something related to the content, the video streaming and all. There you might want to like explain the CDN also a bit. That definitely going to increase your marks. Okay, so we understood about, okay, so CloudFront is a famous CDN by Amazon. So I'll switch back to my previous color. Okay, so the CDN, Amazon CloudFront. This is a famous CDN. Okay, so now we are coming to relational and non-relational databases. We also have searching and analytics, right? I'll come back to it, right? But first of all, let's understand relational and non-relational databases. Okay, caching we understood, relational and non-relational databases. When to choose which type of database. Okay, so relational and non-relational. First of all, first point, whether your data is structured or non-structured. right? Let me write it down. Structured. And yes, I hope you're observing that I have tried a lot to improve my handwriting. In previous videos, I did not want to watch my own video because my handwriting was so bad. So that's why I tried to improve it. I'll improve it with time. So relational, structured data, non-relational, non-structured data, unstructured data basically. So unstructured data. What do I mean by structured and non-structured data? Okay, so the data which you can actually feed into a table. Now a table, let's say this is a table, right, has fixed columns, right, and unlimited number of rows you can have. Let's say we are building a database for our school admission website, right? So here definitely the data is going to be structured. Why? Because every student that is taking an admission, who is taking an admission, is going to have a roll number, is going to have a first name, is going to have a last name, is going to have a class which is allocated, and is definitely going to have a date of birth, right? It's not like that one student will have like properties, various properties like 4 hand, 6 hand. It's not like that, right? All the students are going to have the same features, right? These are the features, and you can store thousands of data, thousands of students into this table. This is a structured database. You can use a relational database for such purposes, right? What are relational databases examples? Examples are PostgreSQL, very famous SQL database, right? MySQL, SQL Server, Oracle SQL, right? So these are some of the relational databases that you can use wherever your data is structured. So first of all, let's say an interviewer has given you one problem statement. Check it out whether the data is going to be structured or not, right? Now let me give an example of non-structured, unstructured data. Then you will be able to relate it in a very better way, right? So let me, I don't want to clear it, but I'll clear this table. Okay. So unstructured data. Let's say you are building one product catalog. Let's say Amazon, right? So in this Amazon, you will have various products, right? So let's say one product is electronics item, right? So an electronics item, let's say this is my schema. Electronics item is going to have definitely a name. It's a TV or it's whatever it is. It is going to have a height. It is going to have a weight. Then it is going to have a power, like how much watt does it consume, or at what ampere does this device work, right? Power or ampere, right? Then screen ratio, aspect ratio of the screen, right? So that might be there, right? But let's say in the same product catalog for the same Amazon, you have a food item, right? Let's say food item, right? Let's say bread. So bread definitely will have a name, but bread will have grams, like weight, right? So weight also we have, okay, that's fine, right? Weight we also have it here, right? But here we have expiry date. Expiry date, it is not there in electronics item, right? But it is there in expiry date is there in bread, right? Then this bread will have ingredients like wheat or sugar or salt or something, right? This electronics item is not having that ingredients. Here my data is not structured, right? Some part of my data or some data points is having these features, some data points are having these features. Now I'm confused. So you don't need to get confused. We have non-relational databases with us, where you can store unstructured data also, right? You can store unstructured data. In here you have like there are various types of non-relational databases, but here the schema of your data point, the schema of your entry may not be consistent. It can change from various products, from product to product or from document to document. Various non-relational databases are there, right? We have one famous, if you're a beginner, Cloud Firestore. Cloud Firestore is a non-relational database. Then you have this one, MongoDB. Then you have Cassandra. It's a non-relational database, right? Or many non-relational databases are there, right? So Cloud Firestorm, MongoDB, Cassandra, or where there are like, now I'll come to the types of non-relational, then I'll tell you about AWS, Neptune, or various types of non-relational databases also. Okay. So this is what the relational versus non-relational means. Now here we only differentiated on term like on the basis of this thing, structured and non-structured, unstructured, right? But there is one more point that I want to bring here, right? And there we come to asset properties. The asset properties. What are these asset properties? These asset properties are applicable to relational databases, right? So one more way of choosing or choosing between relational and non-relational databases. Let's say you are given some problem statement, and there you can see whether this problem scenario, in this problem scenario, we have to apply asset properties or not, right? Asset properties or not. So what are these asset properties? A means atomicity, C means consistency, I means isolation, D means durability. Okay, so atomicity means let's say I'll give you an example where definitely we are using relational database. Okay, payment app, let's say Stripe, or let's say any payment app, Razorpay, right? There what or banking, any banking application, right? So basically whenever you are building a banking application, you have to go with a relational database. Why? Because asset properties are required there. Atomicity. What is atomicity? Either the payment or the transaction will be successful or it will fail. There is no middle point. What I mean by that, let's say I want to send 10 rupees to my friend. It's either the transaction will happen or it will fail. It's not like that it will be debited from my account and it will not be received by my friend. It happens sometimes with GPay, Google Pay, and Paytm, but the money returns back, right? It's never like that that money will never be returned, or the payment is in somewhere in between, that from my point the entry is debited, but in my friend's account the entry is not credited, the payment amount is not credited. If this used to happen, if these things or these failures started happening, then banking transactions or banking applications are like useless, right? But because we have atomicity property with relational databases, this can never happen. Either the transaction will be successful or it will fail, right? Then we have consistency. Let's say my balance is 500 rupees, right? And my friend's balance is 700 rupees. If I send like 10 rupees from my account to his account, then my balance will be 490 and his balance will become 710. Currently, before the transaction, the balance was 1200 total. After also, the balance will be 1200. Okay, this is consistency. Data should be consistent before and after the transaction. It should not be, there should not be a gap, right? This is consistency. Isolation means millions of transactions can happen at a particular instance. Simultaneously, thousands and millions and billions of transactions can happen. This is isolation, that every transaction is isolated from another transaction, right? So this is isolation. Durability means even if the system fails, even if the server fails or the system fails or my whole application fails, my data will be durable. My data will be stored. My data will be persistent. My data will not be lost. This means durability. And all of these properties we want in payment applications or banking applications. And these properties are the properties of relational databases. So see, wherever or in the problem statement, if you think that asset properties are required, then go ahead with relational database. PostgreSQL, MySQL, SQL Server, Oracle database, it's your choice, right? But relational, you have to go with. Or if you do not need these asset properties, then you can go with non-relational database. If you think that your database can store, like if your data is like unstructured, go with non-SQL database, no SQL database. But if these asset properties are required, then you have to go with relational database. This was another point which I wanted to tell you. Then is CAP theorem, right? This is again a way of understanding or choosing whether to go with SQL or no SQL databases. C means C means consistency, A means availability, and P means partition tolerance. Okay, so consistency means, so first of all, these are the properties, or it's kind of a theorem, right? I don't want to like go into the deepest part of this CAP theorem. This is a part of system design, but this is important to understand to choose a database, right? So in any system you take in this world, all of these three properties cannot coexist. Only two properties can exist together. Any two. You take any two. Only two properties can exist in a system. Consistency means, let's say I'm building an Instagram. Okay. So let's say I posted one photo. So consistency means that every time whenever I post a photo, all my friends should be able to see at that particular instance itself. This is consistency. But in such systems like Instagram or social media, that's not a requirement. So it's okay if consistency is not there. Let's say if I'm posting a photo and some of my followers are seeing it now, and if some of my followers are seeing it like after 5 minutes or 2 minutes or 1 second, that is fine. So consistency is not required in social media applications, right? But availability is required. But consistency is required in transactions, in payment transactions. Yes, consistency is required, right? Availability is kind of required in both. Like I would want that if I want to like open a social media application, it should always be available. I should always be able to see my feed. So this can again be a requirement, non-functional requirement, right? From the system, in the system design, right? Partition tolerance means, so this thing actually becomes an issue in SQL databases, right? Because whenever like we get like millions and billions of data points to store, then we have to divide the servers, or we have to bring another server, right, and attach it, right? Then the new data points that are coming, they have to be stored in the new server, right? But partition tolerance says even if you are doing sharding, that this means sharding, even if you are bringing a new server or doing the scaling, the horizontal scaling, the user should not fail, the system should not fail, right? Your system should be tolerant to these partitions of servers, partitions of databases, right? So this thing becomes a problem in SQL databases. Why? Because in SQL databases we have tables. In tables we have to do joins, right? Joins we have to do, and joins cannot be done on two different tables. Like it becomes difficult, right? So this is what CAP theorem is. It's a huge topic. I won't go in deeper, but this three properties I wanted to teach you, right? So this is CAP. Now document databases. This document-based databases are a type of non-relational databases. Non-relational databases. Okay, non-relational database like MongoDB or Cloud Firestore or Cassandra, right? There are a lot of non-relational databases. So document databases, in these document-based database, what happens is there is a collection. Then you have documents. You have documents. All of these documents have document IDs, unique IDs. No two documents in the collection should have like same ID. I'm sorry again for my handwriting. This means ID. ID. Okay. I don't know what it is looking. It's looking like 10. Okay. Okay. So in non-relational databases, in document-based databases, which is a type of non-relational databases, we have collection and we have documents, and we can have multiple collections also. And again, they will have documents. Let's say I'm building an e-commerce application. There, my one collection can be for products, right? One collection can be for orders. One collection can be for cart, right? So this is what document-based database. Every document means one schema. And again, as I told, in this non-relational databases, every document can have a different schema, right? So this document, if it is for like let's say storing bread, this can have a different schema. Let's say another document is for storing a furniture item, it can have a different schema, right? So schema is not an issue in non-relational document-based databases, right? Famous is MongoDB. I would like recommend that if you are building an e-commerce application, then these parts you can store in MongoDB, right? Let's go ahead. Key value pair databases, again, Redis, I would suggest. We have already seen what is this, right? Memcached. So the information, let's say some user related information, let's say user coordinates. Let's say if I'm located in India at this particular latitude and longitude, that latitude and longitude, if you want to like fetch whenever you want to open the app for this user, then what you will do to the Redis, you will pass the user ID, and this user ID will actually be storing the coordinates in the Redis, which is a key and value database. So whenever I will be opening my app, the server will quickly fetch my coordinates and give it to my application so that I can do whatever I want to do. So that's how the key value databases work. I hope this is clear. Okay, AWS also has DynamoDB, which is a key value based database. So now we understood key value databases. Next is columnar database, right? So in columnar databases, what happens is in PostgreSQL, you saw that we have like columns, fixed amount of columns, and you can have multiple infinite rows. In columnar databases like Cassandra, what happens is your rows are fixed, but you can have like unlimited columns, like many columns you can have. Let's say one entry is there, you add a new column. One entry is there, you add a new column, right? So this is a columnar database, and this is required, or these databases are highly useful. Cassandra type databases or columnar databases are highly required whenever your queries are fixed, but your data records are a lot in number. Let's say my device is there, or the Apple device is there, or some device is there, which sends the CPU utilization of my laptop or some device to my server, to the Apple server, and they have to store this here. Or let's say in ride sharing applications, right? Whenever you opt for a Uber drive or a Ola drive, there the location of the driver and the customer are sent to the Ola server or the Uber server at like let's say every 5 seconds, so that the driver is not doing something wrong or customer is not doing something wrong, right? So that's why here there we have to send that information, send that location coordinates at every 5 seconds to the database. So there we have to need some columnar databases, because the queries are less, because you are not going to like query that location database every time, right? But once in a while, let's say something went wrong or some accident happened, then you have to fetch that database. So queries are less, but data points are a lot. Then you have to use columnar database, right? Next is graph database, like AWS Neptune. Neptune is a graph database. So I'll write it down. So this database you can use when you are building a social media application, right? So what happens in social media application? Let's say this is me, and let's say these are my followers. So again, if you have not followed me on Instagram and LinkedIn, please follow it, right? Please follow me, because I regularly post some cool stuff there. So now coming back to the social media application, let's say you're building, and let's say the interview has given you a problem statement of social media application. Let's say this is me, and these are my followers. So I am connected to my followers, right? Now what can happen is these followers, I'll change the color, right? Let's say this is any one of you, right? Any one of you. Let's say Raj. Raj also has some followers, or he's also connected to some people, right? Let's say these are his followers, right? Now he is connected to these people. Again, there must be, let's say, someone named, I am very bad at names. Let's say Raj 2. I don't know, I am not able to get any name. Raj 2. And he is again also having some followers. He is connected to these followers. Now, these type of databases, the graph databases, are very good for storing such relations or storing such social media networks, because at some point of time, I may get a suggestion of following this guy or following this girl, right? How is that happening? Because these graph databases are very good in storing the relations or finding the relations. How or what are the chances of me getting connected to this person? Yes, these are like AI models or AI recommendations, but these type of databases, the graph databases, are very good for storing such relations and storing such information where there are connections, first connection, second connection, third connection, right? So these graph databases are used for such use cases. I hope this is also clear. Now, before we jump to the statement or the problem which was asked to me, I'll get back, and we forgot to see two use cases. One was for searching and one was for analytics, right? Analytics, so there are certain databases, or if your problem statement or if your system design requirement needs some kind of analytics, then you can use the databases which are good and storing like billions of databases, and you can query those databases for certain analytical queries. Like let's say my database is storing like billions of users. Now I want to make a query which gives me those users who are buying electronics item from this date to this date. So such databases, some examples are like HBase or big Hadoop, right? So these are the databases which are good for analytics purposes. So you can give that example. What is this? Let me remove this. Okay. So analytical databases, HBase and Hadoop are some examples. So I'll write it down. Getting back my color. This is not the same color, but okay. HBase and Hadoop. Okay, so these are analytical database. Searching. So searching is very important. I'll make a separate slide and explain you that searching thing. Let's go to non-relational databases itself. Combination database we have to understand. First of all, I'll teach you. Let's understand it here. Searching. So searching means the text search databases. So these are actually not databases, but these are copies of your databases, right? So what happens? Let's say you are storing some users information in MongoDB, right? You have like various documents, and all one document means one user, right? So now you have to search your client application, your mobile application. On your mobile application, users can actually search for a user, right? Let's say Akshat Madan. I want to search, right? Now the normal MongoDB database may not be able to do it, but these searching features, these searching modules, or these searching based databases, some example is like Elastic Search, Solar Search, or Elastic Search, right? These are very good in doing the searching part. How? Because what they do is, whenever you add a document or whenever user is created, his document is created in MongoDB. What they do is they listen to MongoDB collection, and as soon as a document is created, they copy that complete information in their database also, with them also. And now these are very good in doing the text search. Let's say I'm searching for AKSHIT, right? Now as soon as I press A, the query or the API will go and hit this searching database and see, are there any documents that start with A? The searching database will return yes, many are there, like millions are there. Then I'll write K. Then AK will go to searching database and see, okay, are there any query or document that start with AK? Yes, thousands are there. AKS, yes, 5 are there. AKSH, 2 are there. AKSHIT, yes, 1 is there. Here the user, this is your document. So this is called like, now this is like normal searching. Now Elasticsearch and such type of searching databases or searching modules also have fuzzy search functionalities. Now what is fuzzy search? So yes, this is very important. I'm teaching you because your requirement, let's say you're searching a product in Amazon. So you can explain this to your interviewer that if there is such requirement for searching, I can apply this Elasticsearch database, right? So what is for fuzzy search? AKSHTI. If I type this, right? Now also, if I'm not getting Akshat as a recommendation or as in the result, it's not very good user experience. So what is this? This is fuzzy search, where the Elasticsearch will say, okay, the user is telling to search for AKSHTI, but okay, IT can also be the right. IT is there with me. I should return IT document to the user. Maybe the user is doing some mistake, right? So this is called fuzzy search. Okay. So these are the two types of databases, or the things that we missed while I was teaching you this use case of databases. I think now we have covered all the use cases of databases. Now we can go back to, yes, types of databases. Now we know relational RDBMS databases. Now you know when to choose relational databases and when to choose non-relational databases. Document you know, key value you know, columnar you know, graph you know. Now what type of scalability also we understood, what I taught, sorry, horizontal scaling, yes, like sharding and joins may not be possible with horizontal scaling. So in that case is when you have to do scaling of your system, the NoSQL databases might be a good option, because there you do not have any table and joins and rows and columns, right? There you have simple documents. So yes, scalability, I just wanted to teach you that horizontal scaling part, and now you have understood that. Combination database, this was the statement that I was given in my interview, that you are given one, not, this is not a statement, this is a topic, right? So the thing is, topic is, the statement was, you have to build a e-commerce application, right? In that e-commerce application, will you choose one database or will you choose combination of database? This was the exact statement that I was given. Now I had to answer that. I told, first of all, don't directly jump to the answer, right? Think about it, that okay, there's an e-commerce application, right? So think about it. Let's write it down. E-commerce application. In e-commerce application, you will have list down the functions, list down the features. You will have authentication. That means you will have users information to be stored, right? Next will be your products information you have to store, user cart, user wish list, payments you have to do also, and you have to store the transactions also. Then you have to store the orders, then you have to store the history, right? These are the main functions and features of an e-commerce application, right? For users and auth, I know that my user schema is fixed. Every user will have a name, first name, last name, location, address, and some kind of gender, date of birth, everything, right? I can store this in SQL, right? SQL will be good, right? SQL will be good for structured information. If I know that my user's information is structured, I can choose a SQL database, right? Products, I may go with no SQL databases, because I know that this thing, my products catalog will have various schemas. So I may want to go with no SQL. So here I want to teach you that it's not like that every, like let's say an application, it's not compulsory that a single application will be using one single database. It can choose combination of databases according to the need, right? Like here, users want SQL database, store the users information SQL, right? Products want no SQL database, store the products information no SQL. Cart, maybe SQL or maybe no SQL, right? Then payments definitely we will be doing through a SQL database, and we will be storing the payments information, or let's say there is some gift cards or my voucher, my discount points, my cashbacks, right? They can be stored in a SQL database. Why? Because consistency is required there, right? If I'm making a transaction using coupons that I earned, if it is debited from my account, they should be credited there also, right? In the Amazon account, right? So there, for payments, you might be using an SQL, right? So orders, maybe SQL database, because orders are like having the same structure, right? Same schema. So maybe orders can be stored in an SQL database. History is very important. Here I want to teach you, there are certain databases like S3 Glacier is there, but it's not for this purpose, not for textual purpose, it is for object storage. Let's say this is the last topic I want to teach you. Let's say some videos and images are there. Let's say you are building a YouTube, right? And on YouTube, you have certain videos which are like 10 years old and nobody wants to watch it. So those kind of videos you can store it in a database, on which you cannot make queries very frequently, right? They kind of store it in, like one example I would like to give you. One is like S3 Glacier, right? It's a AWS service. It's kind of an object storage, but it stores the objects which nobody wants to fetch it frequently, right? Once in a while, once in a year, you may want to like fetch that video or an image. Then you can store such videos and databases in databases which follows this kind of purpose for storing the information which nobody wants to fetch frequently. Okay, so I think this is clear, and the statement was e-commerce application. I think now you can also answer this, like you have all the use cases, you can see in which use case like which database can fulfill that requirement, and you can answer your interviewer. Okay, so I think we can close this, and one input I would want from you guys is, as I have started the backend series, as I have started the system design series, which videos or which topics you would want me to make videos on, because this is a very difficult problem for me to choose which topic you guys want, right? So it will be very helpful if you guys only give me a topic in the comment section. So I hope you like this video, and I hope you guys are enjoying my videos and stuff. So I think that's it. We can wrap the video here. So till the next video, keep coding, keep innovating, and thanks a lot.